Combination reaction.
We'll require quicklime, distilled water, beakers, spatula, glass rod, test tube, dropper and lime water. Take a small quantity of lime water using a spatula and transfer it into a beaker.
Thermometer.
Glass rod. Slowly add water into the beaker so that quicklime remains submerged in the water. Quicklime reacts vigorously with water to produce a suspension of slaked lime, releasing a large amount of heat. Leave the beaker undisturbed for some time. A clear solution of lime water appears as the suspension of slaked lime settles down. Take a small quantity of lime water using a dropper and transfer it into a test tube. Then cork the test tube with a cork and insert a glass tube through the hole in the cork into the test tube. Blow exhaled air into the test tube through the glass tube. On blowing exhaled air, which contains sufficient CO2 gas, it turns the lime water milky. In this reaction, quicklime and water combine to form a single product, slaked lime, calcium hydroxide, so it is a combination reaction.
Decomposition reaction.
Take a small quantity of ferrous sulphate crystals, FeSO4, 7H2O in a dry boiling tube. Hold the boiling tube with a test tube holder. Heat the boiling tube over the flame of a burner. On heating, ferrous sulphate crystals lose its water molecules and form white-colored crystals of anhydrous ferrous sulphate, FeSO4. On further heating, anhydrous ferrous sulphate decomposes to form dark brown-colored ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3 gases. The gas emitted has the odor of burning sulfur. In this reaction, a single reactant FeSO4 decomposes to form three different products, Fe2O3, SO2 and SO3. So the reaction is a decomposition reaction.
Single displacement reaction.
We will require copper sulphate, iron nails, distilled water, a beaker, measuring jar, test tubes, 2 clamp stands, a piece of thread and a glass rod. Take sufficient quantity of distilled water in a measuring jar and pour it into a clean beaker. To this, add a required quantity of copper sulphate. Stir the contents in the beaker using a glass rod until the copper sulphate crystals in the beaker dissolves completely. Pour sufficient quantity of copper sulphate into a test tube. Clamp the test tube to a stand. Then pour sufficient quantity of copper sulphate into another test tube. Clamp this test tube to another stand. Take 2 iron nails. Clean these by rubbing them with sandpaper so their color appears grayish. Tie one nail with a thread. Immerse this into one of the test tubes containing copper sulphate solution. Keep the 2 test tubes undisturbed for about 15 minutes. After 15 minutes, the color of the copper sulphate solution containing the iron nail turns light greenish color. whereas the color of the solution in the other test tube does not change. The greenish color of the solution is due to the presence of Fe2+ ions. Remove the ion nail from the solution. Compare it with the other nail. There is a brown coating of copper on the nail that was dipped in the copper sulphate solution. The other nail retains its grayish color. In this reaction, the ferrous ions displace copper ions from the copper sulphate solution. So the reaction is a single displacement reaction.
Double displacement reaction.
We'll require sodium sulphate, barium chloride, dilute HCl, a beaker, conical flask and test tubes. Take a small quantity of barium chloride in a test tube and transfer it into a conical flask. In another test tube, take a small quantity of sodium sulphate and transfer it into the conical flask containing barium chloride solution. A white precipitate of barium sulphate is formed immediately. This confirms the presence of sulphate SO4 2- ions. Stir the contents of the conical flask and keep it undisturbed for some time. The precipitate of barium sulphate settles down. Decant the upper solution from the conical flask into a beaker. Then add a small quantity of dilute HCl into the conical flask containing the precipitate. Swirl the flask well. The white precipitate is insoluble in dilute HCl. In this chemical reaction, sulphate ions are displaced by chloride ions and chloride ions are displaced by sulphate ions. So the reaction is a double displacement reaction.